Hello everybody. This is a specific video for 2025, just primarily for students who are kind of jumping into algebra really for the first time this year, or anyone who wants a really quick refresher on the basics of two-step algebra. So as we talked about in class, every algebra problem will come down to either one coefficient on two constants or one constant and one coefficient on both sides. Okay, so every algebra problem you'll ever do will end up with these last two steps. That's why it's so important that we really get comfortable with it. All right, so we're going to go over a couple of things just like we did in class, just so you have something to refer back to. So over here, there are two main questions that you need to start asking yourself when we get down or when we're dealing with two-step algebra. Now, again, I have a coefficient and two constants. We'll get into that in a moment. The first one is the number one question that if you get stuck, you can ask, how is the number attached to the variable or to x? In this one, you'll notice that on this side of the equal sign, there is no x. So it's not attached. So we don't have to worry about that number. We always want to try and get the numbers away from our x. The end of all algebra should end up with x equals. So once we know how the number is attached to x, we are going to use the opposite operation to cross the equal sign. So this is how we cross the equal sign. Okay, there's some other ways to do it. There's some shortcuts that I'll show you as you get up into the higher grades. But for now, I would like to see really solid notation in your work, because this is what's going to lock in these skills. So you have to use the opposite operation to cross the equal sign. Now, let's just take a look at a couple of operations. So over here, if I have, say, a -4, what is the opposite of a -4? Remember, in algebra, we don't have pluses and minuses anymore. These are little blocks. That's 2x. This is +3. This is +7. Just like in integers, when we start looking at everything as an addition, an and, it allows us to move things around in a different way. Okay, that's that higher level mathematical thinking that we're getting into in grade 7, 8, and especially in grade 9. So the opposite operation of -4 is going, well, what do I have to add to -4 to get to 0? It's called a zero pair. So this is going to be +4. Don't overthink it. Okay. What about +10? What's the zero pair or the opposite of +10? Oh, I wrote positive. It's going to be -10. Okay, so you notice how this is just switching the signs. Similar to when we subtract integers, we add the opposite of the second number. We are just looking for that opposite to cross over the equal sign. So these are called constants. Remember, a constant is a number. If you ask me for 2 pens and I give you 3, that doesn't make sense. Numbers are constant. So anytime you have a number with a sign, remember, if I have this number, 4, what's its sign? Positive. It's always going to be positive if there's no sign. So anytime you see those constants, that is just that. The only way we're going to move that across the equal sign is by using the opposite operation, and those are always going to be addition and subtraction. Now, there is going to be a time when we do the same thing for coefficients, but that's when we have coefficients on both sides. So this is our zeroing out phase. We have to zero out. We're going to zero out our constants in two-step algebra. Again, down the road, we are going to zero out our coefficients if I have them on both sides of the equal sign. We'll get to that later, though. Right? The next one is our coefficients. So our coefficients, these ones are a little trickier to get your head around, right? So coefficients are not constants because x could be any number. Right? We don't know what it is yet. So the whole process of algebra is to uncover what that variable is a representation of. In this case, remember that anytime I have a number that's next to another symbol or a variable, that is multiplied. That's implied multiplication. So in this case, if I have 4x, that's 4 times x. If you want, you can put a little dot in between. That is a multiplication. So in this case, to move my coefficient, a lot of people get confused that the coefficient is 4x. The coefficient is just the number attached to x. Okay, so the coefficient is actually 4. It's not 4x. The coefficient is 4 because it's attached to the x with multiplier division. So in this case, I ask, how is the number attached to x? The 4 is attached with a multiplication. What is the opposite of multiplication? It is division. So what we're going to do is we're going to divide by that same number. Remember, the goal is to have 1x, not 0x. If we subtract 4x's from this, we end up with 0. That doesn't help us. We're just moving things back and forth. But if we divide by 4, what that's going to give us, it's going to give us 1x. So remember the property of 1, when you were, let's do this. What's 10 divided by 5? 10 divided by 5 is 2. Why? Because back in grade 2, 3, we talked about if I have 10 things and I put them into 5 groups, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10 into 5 groups. How many are in each one? The answer is 2. So the property of 1 is, I don't know why it takes so long to figure out, but it does for some reason. If I have 4 things and I put them into 4 groups, how many things are in each group? Well, it's 1. So whenever we divide a number by itself, anything, 15 divided by 15, that's 15 groups. Take 15 things, put them in 15 groups. That's going to give us 1. The property of 1 allows us to finish the last step of all algebra. So in this case, I go 4 divided by 4. That's the opposite. So the opposite of multiplied by 4 is when we divide by 4. Same thing down here. This is a divide by 3. The opposite of divide by 3 is to multiply by 3. Now, I want you to notice the notation I use. I'm using a bracket. In algebra, whenever we're adding something to an equation, we want to put a bracket around it so it shows that we're changing it. So this way, if I do it on one side, I'm going to use a bracket. I'll do the identical thing on the other side. Okay, so hopefully that clears up the opposite operation. Right? In grade 7, this is as hard as it is where I can mark you on, pretty much. Okay? So the last thing is this rule that what I do to one side, I do to the other. And remember, in class we talked about this, that teeter-totter. We don't want to launch our little brother or sister off the teeter-totter. So if I have 3 things on this side and 3 things on that side, if I take one of them off, the left-hand side, in order to maintain equality, I have to take one off the other side. So our equal sign literally is this balance. Equality means that they're balanced, they're the same. And in algebra, we don't quite know what this number is yet, so that's why we're going to just keep on balancing as we go. And the way we do that is, as I said, so there's a positive 1, the opposite is a negative 1. This is going to leave me with positive 2 on this side. If I remove 1 on this side, that's going to give me positive 2 on that side. I've maintained equality. So what I do to one side, I do to the other. And from a routine standpoint, whenever you do something on one side, when we're crossing the equal sign, just do it right away. So we're going to look at the GG trays. All right, so I would highly recommend that whenever you start, we're going to take the whole term, which is the sign, the number, and the variable. We're going to do that in a bottom tray. Coefficients, heavier. There's more than one thing. We're going to support that. Our constants, we're going to do with an upper tray. If you want to use highlighters, you want to do different things, come up with your own system. That's how this system was developed. I'm going to use different colors just to make it really clear. So here's our problem. Positive 2x coefficient. Say it in your head whenever you do it. I have positive 3, and on the other side, I have positive 7. So here we go. There is my coefficient tray. I have one coefficient. Now, I've got 2 constants. I have positive 3 and positive 7. Notice how I take, what's going on there? There we go. Sorry, my computer just shut down. Notice how I take the sign. There should be no gaps. This is not 2x plus 3. This is 2x and positive 3. So in this case, our very first phase is going to be our 0 out phase. Okay, that's our very first phase. And the way we're going to do that is we now have to ask the question. First question, how is this 3 attached to the x? Well, it's attached with a positive 3. It's a positive 3. If I'm going to take that positive 3 off of my balance beam, what do I need to do? I need to use the opposite operation. Okay, that's the first thing. So the opposite of positive 3 is negative 3. What I do to one side, I do to the other. Okay, so you see how I balanced it. I know that's going to work. I draw a line. Why do we draw a line? If I give you 8 minus 4, we draw a line. 8 minus 4 is 4. This is our vertical equal sign. So I want you to draw that vertical equal sign. Now the nice thing is here is I can go 7 minus 3 is going to give me 4. Positive 4. Okay. Some people like to actually put a line down the middle, so you kind of, it's like the version of that little balance beam. You feel free to do that. You can do that all the way through university. Okay? It doesn't matter. On this side, I get positive 3 and negative 3. Well, that equals 0. So instead of putting 0, what we're going to do is we're just going to cross it out. Because what we're saying is that I've gotten rid of that number on that side. Last thing I'm going to do is I'm going to bring down my other term. In this case, I only have 1. So now I have positive 2x equals 4. I'm just going to do this again so it's very clear. The reason we always want to move the constant first is because they're both the same kind of term. We want to combine like terms across the equal sign once we get a bigger problem simplified. So in this case, I have one red and one blue, or one coefficient, one constant. So we go back. How is the number attached to x? Well, just like I was talking about before, this is attached with a multiply. So what's the opposite? The opposite is divide. 2 x's is going to equal 4. So if you think about that, if I have x and x equals 1, 2, 3, 4. There's my little balance beam. Well, what would 1x equal? One of those x's has to be equivalent to 2. So I know the answer is 2, x equals 2. But algebraically, the way we do that is we actually are going to divide each side by half, or by 2. So here I'm going to put a line underneath, just the coefficient, and I'm going to write a 2 underneath. I've divided by 2. Do you see the property of 1? Property of 1 means I have to have the same number on top and below that division or fraction line. What I do to one side, I do to the other. Okay, so there it is. This here, this is my property of 1, right there. My first step was 0 out. Next one, property of 1. The last thing I'm going to do now is just solve. 2 divided by 2, well, we know that's a property of 1. That's going to give me 1x. 4 divided by 2 is going to give me 2. We put it in a box. Okay? If for some reason the x is on the other side, we do have to write it with the x on the left. Right? Put it in a box. We're good. Now, we're going to verify. This is the step that most of you are not going to do, but is actually required. So now I'm going to write down my original equation, plus 3 equals positive 7. And I'm going to insert the answer I got in for x. A lot of times we'll just have x equals. Okay? If I give you a pen, I don't go, here is one pen. I say, here is a pen. This is an x. So I'm going to write my 2, put in the bracket because we're substituting in. So that shows me that I'm substituting. Plus 3 equals 7. Now we just serve order of ops. Multiplication first. 4 plus 3 equals 7. 7 equals 7. If those two numbers are the same, that means I got the question right. Right? So we have 0 out phase, we have a property of 1, we have the box, and then we have the verify. Takes a long time, but that's what makes it kind of fun. I'm going to do one other problem, and I'm going to show you the hardest grade 7 problem that you're going to see that I can mark you on. I'm just going to leave this out, okay, because the whole thing is going to work the same way. All right, so this time we're going to go x divided by 2 and negative 4 equals 2. So let's go through it. First step, get your highlighters, get your pen, get whatever. You can do it with a pencil too. I just find that it's a little easier if you have a slightly different colored pen. So there's my, what is it? What is it? I can't hear you. It's a coefficient. It has a buddy. Okay, it's attached by division. I have 2 constants. First thing I need to do is I'm going to use my zero out phase. I have 2 blue, I have 2 constants across my equal sign. I have to combine them. So I've got negative 4 on this side. How is it attached to x? With a negative. The opposite is going to be positive 4. What I do to one side, I do to the other. Say it out loud. Do it in your head. Every time you practice, do it. Okay? It will accelerate your learning more than you can possibly imagine. So I get 2 plus 4 on the right-hand side. That's going to give me 6. Positive. Here I get 4 minus 4. That cancels out. I'm going to bring down my other term. So I get x divided by 2 equals 6. And if you think about this, we can get the answer without doing any more work, because this is saying x divided by 2 is 6. Right? So we only know what half of x is. If half of x is 6, what's all of x going to be? Well, it would be twice as much. Right? So algebraically, what we're going to do is we're going to take a look. How is the number attached to x? It's attached by a divide. So this is where those brackets come into play. In order to use the property of 1, I need to have the same number on top and below my equal sign, just like that. So here I've multiplied. Over here, I do the exact same thing. Doesn't matter what side you write it on. So now, 2 divided by 2 is going to give me x, 1x. This is going to equal 6 times 2, which is 12. There it is. Last step, verify. So how do we do it? We write down the original equation. Yes, it's a lot of writing. Welcome to Big Kid Math. Equals 2. I'm going to substitute in the value I found. 12 divided by 2 minus 4 equals 2. I'm going to slide this down. 12 divided by 2 is 6. Minus 4 equals 2. Don't leave it there. We're going to go 2 equals 2. Did we get the same answer? Yay, we did! Check mark. We got the answer right. Okay, so that is the video on 2-step algebra with the new setup. I hope that helps. We'll see you when we see you, and the next thing we're going to do is we are now going to add x's to both sides. The cool thing is, all you have to do is subtract the whole term in order to zero it out from both sides. Okay? All right, we'll see you guys when I see you. Thanks.